Hello, everyone. We are trying to do PCA, which stands as Principal Component Analysis. Principal Component Analysis is used to reduce the dimensions of variables. It is not usually the case where we can show the X and Y variable in X and Y axis. But if there are more than 2 or 3 or maybe n number of variables greater than 3 or 4, it is not applicable to visualize them in the two axes. So for this case, we use PCA, Principal Component Analysis. So we are trying to do this in R. For demonstration purpose, the dataset of top 100 billboard from Tidy to Stay has been used. All the codes have been copied and maybe a little modified, but actually they are all copied and has been used to generally to briefly go through once, and maybe we learn some steps in the process. And we are only skimming through the codes very quickly. For the whole PCA, only one code is involved, but everything other than that, it's all related to maybe data preparation or visualization and things like that. So here we have, at the beginning, here we have the package called Tidy to Stay R, and we can load the data from td load with the dates in double quotes inside the parentheses. It comes as a list. I have already done this one. If you do this, it comes as list. So let me close all this. So it comes as a list, and from this list, we try to retrieve the data. And we have here, this is the billboard by using $sign or by using double square brackets inside the double quotes. We can view the data set if you like. For understanding the data set, also we need to know, we need to have a true understanding of the different variables. Here we are not doing that. We're just scanning through the codes. That's what we're doing right now. So we load the live view tidyverse, and from the billboard, we are selecting based on the two variables we have. We're selecting, or we are filtering weeks on chart if that is 1, and for instance that has to be 1. And these two variables are again in the we need to understand them, and we might want to understand what they actually mean. So we add the new column, mutated from the week ID and converted into month, date, and year. From that we format it as a year. And this filter and muted comes from the deploy package. And here we are using the pipe operators. They are very popular. And from that, we'll select this as variable, and we want to join the two data sets based on the song ID. And so we have this audio features already from here, and we are trying to join, or join the two data sets by song ID, and it matches the column and checks each rows, and finally builds this new variable called feature selected. So here we are preparing the data for PCA. So we are selecting different variables from feature selected, and we want to drop, and we're writing drop NA, or it means to exclude if there are no entries in any rows. And finally, this is the thing here, PR comp. This is doing the PCA analysis. We are selecting everything except the year, and we are using a pipe operators again, and here it is scale equal to true. That means it involves something to do with standard deviations, and we can finally visualize this has all been done again. So when we view, it is actually something else. However, if we print this, we get this one, but actually retrieving the data or getting all the other analysis is difficult, and the data are all in list. We can view the PCA rules, but again, accessing them in tabular form is difficult. So for this, there is a package named Broom package, and it is used, which helps us in accessing them very easily in tabular form. So here we use it's tidy. This is the function here, and we want to use matrix eigenvalues, and there are different types of functions within this package, and it retrieves the data. If you run this here, we have this in something similar to in a tabular form. And again, there's another function named augment, and what it does, it changes the everything in table form and adding again the new, something from the other data set. So basically, it's doing what it's doing is it's adding the year in a PCA in the indiv. It's a new variable. So if we run this, and again we have already run this one, and so basically this Bloom package has three main functions. That is a augment and tidy and something called clans. And finally, after getting this one, now we are able to explore them using ggplot, and here we are using a ggplot to run them here, and all these things here. The point shows the year of song creation, and there includes other things, other tabs such as X and Y, and it's providing information here. PC1 is 22% and PC2 11%. The main important thing here is we're using geom point. And also after that, we want to highlight again by utilizing the variable coordinates. We are changing the rows and columns here, and what we're doing right here is we want to change the longer rows to wider columns. But before that, from the tidy function, we are using the matrix equal to rotation. And the main use of this is getting the variable coordinates, helping us to visualize later. And here we are renaming column to variable, and we want to mutate the first word of the first letter of the word to be a capital. And there's another package named ggRepel, and what it does is it stops the two text from overlapping and helps in much more clear visualization. And again, here we are using ggplot, and all things is here geom segment, and here we are using a arrow. Different parameters have been given, and after we have geom text repel, and it does similar function similar to ggplot, but here we are adding a level variable, and we are adding other different parameters again. So, and similar to labs, other information that's shown in the graph. And if we run this again, if we run this, and you might want to see this, and we get this graph pointing each from the center. It is pointing towards coming from the center to different directions. So finally, we add the new variable, that is year, which was excluded before, and we are doing it. First, we find the correlation, and we view this. Here we have new variable added as here, and other things. It's as a correlation, and that correlation is added to the main variable, and then again we finally do the same thing that we have done just before, and we can maybe plot this again. If you run this, what it is doing is just adding the error in that point, and it appears red. So this whole codes are just related to the visualization purpose, I think. But the thing here is to be able to say that all these codes purpose has been based on what the main person who wants to research in that direction. But what I know, or what we really need to know, is there's only one function that from the I think it's our stats package, that's prcomp, and that's doing the main principal component analysis. And what other thing it relates is that the all other thing codes is it might be difficult to interpret just as a learner or a beginner maybe, but if we really want to have that kind of analysis, these all things are just related with the other aspect, visualization aspect, or maybe the preparation aspect. So I think this was a very scheme. I tried to explain it. So I hope this was a little helpful. You can find the code in the links. So thank you for watching. Thank you.